Hey everyone, welcome back to the shop. So in our previous video, we were working on our Harley-Davidson belt drive pulley, this guy right here. We've already got the lathe work done on this. This belongs to our Harley-Davidson mechanic friend, Tim. It's for a personal project of his where he's taken the original chain drive system and he's modifying it to go with a belt drive system. So these are all parts that he has supplied. This pulley right here is the one that he's going to be using. We've already got our lathe work done, but what we're doing is taking the original drum brake system and we're adapting it to go onto this pulley. So no machining on this, but we have an adapter plate that we still have to machine. We're going to get to that next after we finish our pulley, but this will be bolted down to the adapter plate, and then the adapter plate will be bolted to this right here. All right, so we have a couple of hole patterns that we need to machine in this. The first hole pattern is going to be a 16 bolt hole pattern for 1/4 inch through bolts. The bolts will actually come through the backside where the black paint is here and bolts into the adapter plate that we still have to machine. The other hole pattern that we're going to have to make on this side is going to be for the dowel pins. He's got this designed to where there's actually going to be 4 dowel pins on here, 1/4 inch dowel pins, and we're going to be machining those from this side. Those will be blind holes, and he would like the dowel pins to be a slit fit into the pulley here, and then the adapter plate that we machined, that will be a press fit for the pins. So they'll press into that and then slide into this guy right here. All right, so I'll refer to my notes here. I'm pretty sure I've just got to verify again that these are going to be the slip fit holes on the dowel pins, but he has provided some wonderful notes. In the first video, I actually show you the hand drawings that Tim has made on all of these components here. These are copies, by the way, so I've got his safely put in the office there, and I just made some copies so I didn't get his originals messed up, because he did such a wonderful job drawing these things out for me. That was great. So we're going to do this over here in the KBC mill. I still need to break down these vices and get them out of the way, but we'll make use of our Newall DRO and use the pitch circle diameter function on it to lay out the holes where we need to go, you know, our XY coordinates to get where we need to go there. But relatively simple job that we got to do. So let's head over there and start getting the machine set up, shall we? Still set up from that shaft job that we just did. You guys haven't ever used these or don't have any. These are the Octane Workholding T-slot guards. They have them in a couple different sizes, probably a few different sizes for different T-slots, and you can buy this stuff from KBC Tools. It is a great product. It works excellent and helps keep all the chips out of your T-slots when you're not having to use them. So I've been going over a few different ways that I could clamp this down or hold it. And I think we're going to use our most basic method, and that is just setting it straight down onto the table and putting some clamps on it and holding it that way. This side is machined, and that's the side that we referenced in our 4-jaw chuck. And I think if we just set it down on the table like this and put a couple of strap clamps on here, that's all we need. We're just drilling holes in there. There's not a lot of pressure that's going to be forced against the part here, so I think a couple of hold downs is going to work. And in fact, I think just 2 right height clamps on both sides right here is probably going to be more than efficient for what we're wanting to do. So I'm just kind of eyeballing down the center of that T-slot there. So if we go that route, we didn't really have to take our T-slot covers out, but that's okay. Let me get a couple of clamps out. I'll show you what I'm talking about. Like this right here, I think we can just do this. Because of the way the bottom of the clamp is radiused here, I think we can clamp right down on this, and we know that this flange is, you know, sitting against this main part of the casting, the thick part of it. So I think we could just do that right there. And I'm going to put a shim under this side so it doesn't push against the table. And same thing over here. Just go right up against that little flange area. And I think that's going to be more than sufficient for what we need to do. And this is what I mean. I got some brass shim stock here and put this under the foot of the clamp so that this right here isn't digging into the surface of the table there. Do that on both sides, just like so. But I need to get some T-nut studs and some flange nuts in order next. Just getting our T-nuts in there. See if this stud is going to be a good length for us. I think it might. That looks pretty good. Not gonna even worry about these washers. It's gonna be fine just like that. All right, just making sure it's centered. Looks nice and centered there. I think we're good to go. Won't take a lot. That should be all we need. Just do a double check. Good. All right, that should be good. Should be clamped nicely. So of course we got to find the center of it there. We'll do that next, and then we'll get our DRO set up. We'll get our part rough centered with our spindle. I've got a pointer in here and a rule. And let me think. So when we bored this, it was 10.856, I believe. So cut that in half. It'd be 5. Let's just call it 5 7/16. Would be about halfway. Move the handle here. Looks like we're really close already on that one. Not far off. So we're just going to do this so that we'll put an indicator in here and then sweep it in. So that's 5 7/16. Well, I can't get it in that way, can I? How about right here? Will this be close enough for us? All right, that's about it. 5 7/16. 5 7/16, and if we flip it this way, check it that way, yeah, pretty close. Pretty close. All right, so yeah, we'll just put a dial indicator in here, probably a test indicator, and we'll just go ahead and sweep this bore. Now, alternatively, what we could do is use an edge finder and use our DRO for the half command and just feel off both these in 2 directions. But how about we use an indicator today instead? We're gonna use this indicator holder right here from Edge. Do something like that right there. We can bring that. Yep. All right, and I got a test indicator out. We'll use our Starrett number 811 today. I love this one because you can flip that dial, whatever orientation you want. Maybe we'll just do it like that today. Get it in that dovetail and snug it up. Move our feeler in that position there. So I can go back a little further. Something like that. Just making sure we're clearing, and we are. Definitely need to go that direction there just a little bit. One thou on the positive side, two thou. Looks like 1.5. Make a slight adjustment here. Pretty darn close right there. I got some, I don't know, a 1/2 thou fine tuning that I need to do, but that didn't take but a couple minutes to get set up and get indicated in. So that's working great right there. Okay, we've got our part nicely centered here on the machine. We've got our DRO 00 there. So we're gonna go ahead and get this set up for our hole pattern. We'll start with the reamed holes. So I've got my drawing in front of me right here, and this is giving us the dimensions that I need to know for these 2 hole patterns. Both of them are drilled on this 10-inch diameter right here. So you have one pattern that's gonna be 4 holes. You got 0, 90, 180, and 270. And then the other hole pattern, which is gonna be our through holes, we'll just start those at like 11 1/4. It'll shoot over here and start at 11 1/4, but we'll get to that one later. Let's just start with our 4-hole pattern first. So I'm gonna come over to this side. On this particular DRO, to get into our bolt circle diameter function, we go to F2. It's actually called the pitch circle diameter. All right, and the last entry was go. So we use these 2 arrows up here to cycle back and forth. You can go all the way through them if you want. So the first one is gonna be the center point, which we want 0, 0. Just our part, we're basing our origin off the center of the bore. We've already got it 0, 0, and it's gonna base our hole pattern on this 0, 0 entered in right here. So that's good to go. Next command is gonna be the diameter. And our diameter, we want 10 inches. So just simply put in 1, 0, enter. Now we have a 10-inch diameter circle. Next one is gonna be, this is number of holes. Last entry was 6, and we want 4. Enter, there we go. All right, and then this is gonna be the angle of approach, the first hole. Where do you want it to start at? And on this particular machine, the way this is coordinated, the way it's set up is that you would move X. I don't know if it's positive or negative, but you would move X to get to your 0. So it's like on this machine, this would be 0, 90, 180, 270. I want to start at the 12 o'clock position. I just always like that. So here I'll put in 270 degrees and enter. And the next one is go. We're ready to go, so hit enter. All right, so we got a 5-inch, positive 5 inches that we need to move to get to our first hole. So we'll go ahead and move it and see if we're, yep, going in the right direction. So if we move our axis, our y-axis to us, and we just bring this to 0, that's gonna be our first hole location. And that's how this function is based on. So all you do is you cycle through your holes. So that's hole number 1, by the way. And if you use these arrows, you can go to hole 2, hole 3, hole 4, back to 1. So you can cycle through whatever hole you want to go to. So we'll start with 1, and we should be ready to go. So we'll get the tool set up and start drilling and reaming our 4 holes. All right, so just gathering the tools we need. So our first hole is going to be a reamed hole, and we'd like it to be like 1/1000 over. So this is my over and under reamer set. If you don't have a set of these and you do a lot of drilling and reaming, I'd highly suggest investing in one. This set right here was very generously donated to me very many years ago by one of the viewers. I can't remember who it was at the time, but it's been extremely handy to have this set ever since then. So I keep it in the toolbox, and it's very handy. So over and under reamer set, this particular set, it's got this shelf that comes out. So we have our standard sizes, 1/8, 3/16, quarter, 5/16, 3/8, 7/16, and half. And what it is 1/1000 under and 1/1000 over on the reamer. So you can use a reamer and have either a press fit or a loose fit, not loose fit, but a slip fit, 1 thou over. So for our application, we actually want the 0.251, which is this reamer right here. This is the one we'll be using today. And this is one of the dowels that Tim supplied with the job. He gave me a few of these, and I went ahead and mic'd it just to verify that it is going to be on size. And with our mic, it's measuring exactly 0.250. So what we would want is our 251 reamer, ream the hole with that so that it would give it just a little bit of clearance for this to slide in and out of the hole. That's what he requested for the pulley side. Now when we go to do the adapter, we'll come back to this set and we'll pull out the 0.249 and we'll ream it with that so it'll give it a slight press fit in the hole. So we've got that. I'm going to start with just a simple center drill just to spot it. We're going to use just the end of the center drill to spot it. And we need a drill, so we'll pull out our A-Bomb 79 drill index here, and I'm just going to go with a 15/64, which would be one size underneath quarter, and we'll use this guy to do our drilling right there. All right, we got our center drill in there to spot it. What I like to do is verify that everything is correct. So since we know that this is a 10-inch, this is a 10-inch circle, it's gonna be really easy. We'll spot this and then we'll go to hole number 3. This will be hole 2, this will be hole 3. I'm gonna come over here and spot it and just verify that it is on 10 inches, okay? And when I spot these, I mean, I don't go very deep. We're just using the tip of that center drill. Just like that, and then we'll do the arrow. There's hole 2. Now we're going to go to hole 3, which is negative 10 inches. There's our negative 10. Just nice little spot there. And then I'm going to get some calipers or something and measure that and make sure that it is on 10 inches. We got some of these digital calipers set to 10 inches. I'm just going to set that down in a little divot, and that looks good. That should be 10 inches. So DRO is correct. We should be good to go ahead and drill and ream our holes. All right, so we're going in with our 15/64 drill. This is a split point drill that we're going to use there. I'm going to just go ahead and get the full diameter established. And I'm going to use the knee just like that right there. I'm going to lock the quill. Actually, I want to give it a little bit of lubricant. We're going to go in with our anchor lube. Just put a little dab of it in there like that. Lock the quill. So I'm going to bring it up 280 thousandths. He just wanted like a 64th clearance, but since these are going to be the clearance holes that the pins go in, I'm going to give it like 30 thousandths clearance. So we'll just go up 280. One, 2. 80 thousandths. Okay, should be good. Take that out, and I think what I'll do, just to make sure that we have really good accuracy on our reamed hole, I'm going to take the chuck out and we're going to put this in a collet. All right, we got our reamer in a 1/4 inch collet. Just getting rid of those chips. And then we also want another dab of our anchor lube here. I'm just going to bring this down until it touches, and we are ready to ream. I'm going to bring it up with the knee again. I try not to bottom those reamers in the bottom, because I firmly believe that if you use the quill and you come down and you start reaming the bottom of that hole, it's going to start walking out and it's going to cut oversized. So I'm trying to get the most accurate hole as I can. So let's go. I reduced it to 650 RPM. There's 1, 2. There we go. That should be our reamed hole. Let's give it a little clean out and see if our pin fits. There we go. Yep. That is what we're looking for right there. 1 thou slip fit. Worked great. All right. Well, we just got to repeat that 3 more times. Almost forgot we needed to chamfer it too. Just want to touch it. That looks good. That's about a 10 thou chamfer break on it right there. Now we can move on to our next hole. And go to hole number 4. That one moved on me right there, so I'm going to come back into it. Tries to move when I go to lock it. There we go. Close enough. All right, we're 0-0. Just are gonna miss our clamp. .15/64. Just coming into the diameter. Little spot of anchor lube. $100, $200, $50, $60, $70, and $80 right there. Reamer installed. All right, we got our zero going here. One, two. There we go. We got it. Nice fit. All right, just need to chamfer it and we'll be through with that one. All right, let's just hit that chamfer and then we'll move on to the third hole. That's good right there. About a 10 thou chamfer break on it. There it is. All right. Put a little spot of anchor lube on here. Lock lock it in place. We got our 0 set on our knee. One, 2, 80. One, 2, 80. Quarter-inch dowel. There we go. All right, last hole of our 4 reamed holes. So we're going to go to hole number 2. All right, within a 0.5 thousandths, I think that's going to be good right there. Here's our full diameter. One, 2, 80. All right, let's get her reamed. One, 2, 80. Cut our chamfer. Well, it didn't fall in there the way we were hoping to, but that's okay. We got the same fit as the other side there. There it goes. So that's going to complete our 4-hole pattern there with our reamed holes for our dowel pin. And that's completed. So now we're just going to move on to our 16-hole pattern. And that one's going to be just 1/4-inch holes that are drilled. So we may just end up just using our 1/4-inch drill for that. But yeah, we'll just move on to the next hole. We got to get our DRO set up for that, and then we'll get those holes drilled next. I'm just going over my print one more time before we go set the DRO. So this is one of the drawings that Tim has provided for us that shows all the hole locations there. So the 4 holes circled in red, those are the 4 that we just completed, our dowel pin holes. And then the other ones are the 16 holes that we got to go drill now. And we'll just start right here off of our zero position. We'll set it at 11¼ degrees, and you've got 22½ degrees between each hole. That's your 16 divisions all the way around that circle there. And if you look here on this print, this is the cross section of the pulley that we're machining. So we actually have been machining from this side right here going through, and we're going to leave this set up just like we got it because it's nice and true and on center. And we'll go ahead and drill our hole pattern. And the last thing we'll have to do is flip it over on the other side because he wants the other side spot faced for the flange and the washer of the bolt. This other side is the casting, you know, with the powder coat finish on there, so we need to spot it. He wants a nice true face that's, you know, perfectly perpendicular to the hole that we drill. And for the spot facing, I've got a tool on order because I did not have what I needed, but what we'll use is a tool like this. This is a couple examples. You know, something I got really close. This is a 9/16, and I believe this one was like a 1/2 inch right here. But I don't have the size that I need, and I also could not find the pilot that I need. I want a 1/4 inch pilot with a 17/32 diameter cut. These are the bolts that he is going to be using to bolt it on there. It's just it's a nice looking bolt that's finished. That'll be decorative. And this measures 515 thousandths or so. So I just go up one size. You know, the next standard size would be 17/32, 531 thousandths. So that's what I've got on order, is one of these guys, 17/32 with a 1/4 inch pilot. So once we get it drilled, we can just flip it over, and then we can just have this one tool installed in the spindle. The pilot will center the hole. We can get it clamped in place and just simply spot it and then move it around to the next hole. That should be pretty simple. So it's unfortunate that I didn't have the tool that I need and had to get one, but you know, we got to get the right tools for the job. So we got that one ordered. I ordered it from McMaster Car, and they said it's going to be here Monday, today being Friday. But we'll at least go ahead and get our hole pattern drilled now and get that part of it finished up. All right, let's get our DRO set up. So we're still in the pit circle diameter, but what I'm gonna do is just back out of this. All right, we don't have to recenter it. We're just gonna go right back into our pit circle diameter function and go ahead and adjust our dimensions that we need. We're gonna be cutting on the same 10-inch bolt circle. And then instead of 4 holes, we're gonna go 16 holes. And then that's the angle of approach. So we're just gonna start with our 11 1/4, basically start with this hole right here. So 11.25 degrees. And we're ready to go. So we'll go ahead and make our adjustment. This is going to be our hole number 1. And again, you just cycle through to every hole that you want to drill. So if you go back, there's our hole 16. There's our hole number 1. Pretty cool, huh? We'll just start with 1 and go from there. And we're going to put our 15/64 drill back, and we're going to go with our 1/4 inch. So we are using split point drills here, so I'm not going to bother spotting it this time. I feel confident that this short stubby screw machine link drill with the split point is going to work perfect going through that aluminum. All right, we're on hole number 1. Time to get to drilling. Go ahead and speed this up. We'll go with about 1500. That should be good. This first one, I'm going to watch it and just see how it does. I don't see any walking whatsoever there. I'm gonna go ahead and we'll put a little dab of our anchor lube every now and then and see if we can get a little lube on the drill. Like butter. All right, let's see. We're gonna go to hole number 2. Looking good. Hole number 3. 1.379, 1.379. I don't see that DRO moving. without locking the table there. So I think we're good. This one should be straight across. This is hole number 5. Hole number 10. Done. Hole 16. Well, I think that went pretty well. We're going to go ahead and I'm just getting this cleaned up. I wanted to get our chips out of the way so I could see it a little better. And I'm going to go back around the hole pattern here with a chamfer tool, and we're going to cut a light chamfer on all them holes. I want it to look good match everything. So we'll go in there with our little chamfer tool, and I am going to set a stop this time. Since we got 16 holes, I want to make sure that they're all the same depth. Usually what I do, just run it down like that, and then we'll have to, this is the part that I don't like. I need to get me one of those little, they've got these clamps that come up here. I've got one for the do-all. I need to get one for the KBC here. But we'll just go ahead and run this guy up to create a stop for the quill to go against. Like that right there. I'm gonna slow it down some. Knee handle here, I'm gonna drop it down just a touch and then bring it down against our stop that we just set, and then bring the knee up to the cut. Let's see. That looks good right there. I'm gonna go another thou. That looks nice. So we should be able to repeat that on every hole now. It's going to be our last hole for chamfering. Overshot it. All right, there we have it. All the holes are chamfered, and it looks good. That side of the pulley is now finished. I'll get it cleaned up, and from here, we're gonna have to flip it over and get the other side spot face. It shouldn't be very bad at all. That's why I ordered that counterbore tool, so that we can just use the tool with the pilot to line up on our 1/4" drilled holes there, clamp it down lightly, spot face it, and just keep doing that to all 16 holes. So that tool will be here next week on Monday, and we'll get back on that and get it finished up. It's looking good though.